Okay, this video is going to be talking about the other important parts of lines, which is Y-intercepts. So to me, intercept almost sounds like intersect. Okay, so that's what you should be thinking about when you hear Y-intercept is where does my line, intersect or hit, if you want to think of it that way, the Y-axis? Where does it cross the Y-axis? Okay, whatever that number is, that's your Y-intercept. Okay, and because it's hitting the Y-axis, keep in mind anything on that Y-axis has an X coordinate of 0. Because when we graph an ordered pair and we're staying on the Y-axis, it means we didn't move any left or right. So our X coordinate is 0. So Y-intercepts happen when the X is 0. And you can usually write it as, you can write it as an ordered pair, not usually. You can write it as an ordered pair, but you usually just give the Y coordinate when you're talking about the Y-intercept. So you're not going to say, for example, that the Y-intercept is 0, 2. You might say it goes through 0, 2. But that really means that the Y-intercept is 2. You just give that number. Keep in mind in a proportional relationship, which is where this all started, those lines go through 0, 0. So in that case, the Y-intercept would just be 0 because it's the Y coordinate right there. So we have a couple graphs. Okay, and this is going to seem hopefully pretty easy. Okay, we're just going to identify the Y-intercept from these graphs where we're just saying, okay, here's our line. Where does it hit my Y-axis? Okay, so in the first one, it hits my Y-axis right there, and the numbers are a little bit off of their line, so just be careful. I'm going to zoom in here. Okay, it hits it right here, so that Y-axis, that Y-intercept is going to be a positive 5. Okay, here on the next one, we're hitting the Y-axis right there, so our Y-intercept is 4. This last one's a little bit different. It hits below the origin. Okay, it's hitting right here. That's the Y-intercept. Okay, and that just means that our Y-intercept is going to be negative. So in this case, our Y-intercept is -1. So if it's asking for the Y-intercept of the graph, you're just saying, what is the number where it hits the Y-axis? Okay, what's a little bit tougher is what do those Y-intercepts mean when you're talking about some real life situations? Okay, so here in this first graph, it's showing Kelly's movie. Our x-axis is the time watched in hours, and the y-axis is the time remaining in hours. So it's always important to first look at what the axes are representing. Okay, we know, hopefully, even though it's just the first quadrant here, okay, because we can't have negative time. We don't care about the negative parts of the graph, which is why we're only dealing with the first quadrant where everything is positive. Okay, our y-intercept is going to be right there. But what does that mean? But keep in mind that we said y-intercepts happen when the x is 0. And our x is the time watched. So if no hours have passed in the time watching of the movie, okay, this is a 1.8 right here because it's between 1.6 and 2. Okay, if no time has been spent watching this movie, this y-intercept is saying that the movie has a length, I'm going to say runtime, okay, but really just how long it's going to last. So the movie has a runtime of 1.8 hours. Okay, because as time watches increases, which is our x, okay, the amount left, the amount remaining in the movie is going to go down. Okay, but at the start, when x is 0, that means no time has been spent watching it. So the movie must be 1.8 hours long. Okay, the next one we have temperature since sunrise, and we have a lovely sun there. Our x-axis is hours after sunrise. And then the y-axis is the temperature in degrees Celsius, which is why it's not very high. Okay. So here is our y-intercept. It is 4. Okay. What does that mean? Well, the y-intercept is 4 when x is 0. So 0 hours after sunrise. Hopefully we realize that would just be sunrise. Okay. So at sunrise, the temperature, okay, essentially that like our day is starting at, but our temperature is going to be 4 degrees Celsius. Okay, so it's often helpful to say, okay, I know my x is 0. What is the x representing in this situation by looking at our axis? Okay, and then apply that to the situation. Okay.